Welcome to question 7 of the 2015 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for part A of question 7 we're asked to solve log 2 of 6 subtract x minus log 2 of 4 subtract x is equal to 2 for the variable x, where x is less than 4. So we have a log law that says if we have the same bases, and in this case we have the same base of 2, and we subtract 2 logarithms, we can divide the arguments inside them. So therefore we can have log 2 of 6 subtract x divided by 4 subtract x is equal to 2. Next we can work with an equivalent exponential statement to help solve for x. So that will give 6 subtract x divided by 4 subtract x is equal to 2 to the power of 2. So therefore we find 6 subtract x divided by 4 subtract x is equal to 4. Therefore, when we multiply both sides by the denominator 4 subtract x, we find 6 subtract x is equal to 4 times 4 subtract x. So therefore, 6 subtract x is equal to 16 minus 4x. And just be careful to multiply both terms inside the brackets by 4 in that step. And then we can add 4x to both sides, and we would get 3x on the left-hand side. And in the same step, we're going to subtract away 6, so we get 3x is equal to 10. So we find that x must equal 10 divided by 3. So that is our answer to part A of this question. From the examiner's report, we can see that 2/3 of students got that correct, with many students correctly applying logarithm laws. Some, on the other hand, incorrectly cancelled the logarithms out. For part B, we're asked to solve another equation, and this equation is 3e to the power of t equals 5 plus 8e to the power of negative t. So we can write this as 3e to the power of t is equal to 5 plus, and this could be written as 8 divided by e to the power of t. And now usually when we solve equations, we like to have the variable all in the numerator, and at the moment we've got e to the power of t in the denominator. So our next step between this line and this line is going to be to multiply everything by e to the power of t. So therefore we find that this will be 3e to the power of 2t is equal to 5e to the power of t plus 8. And now we can recognise a familiar pattern that happens in these sorts of questions, where we have a number to the power of 2t and a number just to the power of regular t and a constant, which gives us a hint that this may be a hidden quadratic. So to reveal that, we're going to let something like capital A equal e to the power of t, and that will give us this equation. We'd have 3a squared, and then we're going to subtract away the 5e to the power of t, but that's now just going to be 5a with our substitution. And then we subtract away 8, and that's going to equal 0 now. So we have a quadratic that we're trying to solve equal to 0. So we're going to factorise that by looking for the factors of 3 times negative 8 is negative 24 that add together to give negative 5. And we can see that negative 8 and positive 3 would help us do that. So we're going to use that information to split apart our middle term. So we're going to have 3a squared plus 3a minus 8a minus 8 is equal to 0. So from this step to this step, we've just split the middle term up into 2 separate terms. And that allows us to factorise by grouping. So for the first 2 terms, 3a is the highest common factor, leaving behind a plus 1. And then minus 8 is the highest common factor between the next 2 terms, which also leaves a plus 1 behind. And we know that's going to equal 0. And then the highest common factor now is a plus 1, leaving behind 3a subtract 8. And that's equal to 0. So continuing our work over here, the null factor law would say that a plus 1 could equal 0, or that 3a subtract 8 could equal 0. So therefore, we know that a could equal negative 1, but a was simply e to the power of t, so we have e to the power of t could equal negative 1, or we would have a is equal to positive 8 divided by 3, but we know a is simply e to the power of t, so e to the power of t could equal positive 8 divided by 3. And now there's no solution for e to the power of t equals negative 1. And to solve the next equation for t, we need to work with it in an equivalent log statement. So rearranging this, we get t is equal to log e of 8 divided by 3. So that is the answer to this question. From the examiner's report, we can see that 36% of students got full marks for this question, with almost 50% of students receiving no marks for the question. And the examiner goes on to say that the question was not answered well at all. Many students were unable to create the quadratic equation evolved from manipulating e to the power of negative t, which we saw on the previous slide. For those who could get the quadratic equations, many of those students solved using the quadratic formula rather than using a simpler factorising technique. The feasibility of only one answer was generally well handled by students.